the research activities in the measurements group, and Andrea Ferrero is giving next talk.
Well, let me remind something. About 20 years ago, I'm one of the few probably that were there in Villa Gualino, as Mario said before. Valentino Castellani said, we don't want to have a research group organized as ministry in terms of career groups. And there was a big discussion, I remember, I was young, but I remember very well, a big discussion with some big boss that was saying, no, we do have to have career groups, and some others said, no, we have to have a research group. Valentino won, and actually, you may not know, but the department has one more research group, which was called at that time microelectronics, which actually includes people from measurements, people from electronics, people from electromagnetic fields. I guess no one from telecommunication, but all the other people from circuit and theory. So all the other groups were in what I call the mixture groups of electronic department. When we have, after 20 years, to organize this meeting, it's clear that the vision of Valentino was failed, because we organize it strictly as career groups. It's a pity, but why I say so? Because I'm probably the representative of the dream of Valentino. I won in electromagnetic group, I teach in circuit theory, I'm a measurements guy, and I do microwave. So the dream unfortunately failed, but this day today, I really feel it as the possibility for at least the young of us to restart cooperating with everybody. And I'm more than honored that my colleagues in the measurements group, when there was to choose someone to talk to you today of measurements, appoint me. Because myself has been, as I said, broader than just a measurements guy, although I have did my career in the measurements, but I feel myself definitely broad spectrum as a researcher, not just as a professor and as someone who did the career in the university. So, measurements group. The measurements group, those are the people. If we are a small group, those are the structured people. Oh, sorry about that. And what's about the mission? Well, the mission of the measurement group belongs, again, on a long, long story of the electronic department. The story was that we are one of the few universities with a very strong characterization in metrological and measurements and experimental activities since the beginning. Of course, these things evolved in the years, and today we span from innovative sensor instrumentation and measurements technique, software for measurements application, calibration procedure, as well as the spread of the metrological culture inside and outside Polytechnical. This is important as all the other things because the metrological culture is not so common in university. Everybody tends to keep measurements in the lab as something that provides data to somebody else. You have to be proud to have somebody who does the job of fundamental research in measurement itself, in development measurements as it is, not because as a servant of somebody else. It's really, really, really rare. That's what at least I've seen around the world. And of course, it's intrinsically wide spectrum, because anywhere has a quantity, it has to be measured. So these things is really a mission which is practically impossible by definition. Mr. Hunt, that would say. So who are we? Four professors, Andrea De Marchi, Franco Ferraris, myself, and Marco Parvis. I can cite them because we are few. One associate professor, Alessio Carullo, and four assistant professors, Giovanni Costanzo, Massimo Ortolano, Valerio Teppati, and Alberto Vallan. And then we have, of course, several visiting scientists, 3 postdoc, and 7 PhD. The facilities. Measurement means experiments. Experiments require space, which are called labs. So what we're going to talk about are our labs. And when I say our, I don't say measurements groups lab. I say Department of Electronics and Telecommunication labs. Because the purpose of today is to know each other. And so I wish that you feel these labs as facilities that everybody can say, oh, I can do these measurements today. So microwave measurements lab, it was the traditional lab of what I said before, the microwave electronic groups. And it has a commercial hardware from VNAs, vector network analyzer, to microwave signal generator, up to 100 gigahertz spectrum analyzer, probe station, for example, here you can see here, for example, no, doesn't work. You can see here on wafer probe station, we have cryogenic on wafer probe station that obviously can be used for anything. And then we have passive tuner, power meters, amplifiers, everything to make a characterization in time and in frequency domain up to 100 gigahertz, as well as nonlinear characterization, which is pretty unique, as we will see in a few minutes. Then we have a built-in hardware. Built-in hardware means that we built measurement system. We just not call Agile and say, oh, we do need something. No, we build them from basic components, like this is a directional coupler that has quite good performance, up to transistor fixtures, up to complex system like this one, which is an 8-port VNA, which when we designed it and built it was pretty unique. Up to a complex system, measurement system, where what we do practically is developing the software. Then we have automatic measurements laboratories, which are 3 laboratories that allows us to make measurements of several kinds. And they're based on more general purpose electronic instruments like oscilloscope, multimeter, digital acquisition board, mainly commercial one, but as well as top class instruments, something that you cannot get easily, which are, for example, 8.5 digit multimeters, calibrators for electrical quantities. And of course, when you have such kind of things, it's not only to buy the things, you have to be able to use it. And that's where the expertise comes from. So these are the pictures of the labs. As you can see, they look like more traditional electronic labs, but there are some stuff here that we will discuss in a minute. So for example, we do have vibration facility, electrodynamic shaker. We do have thermal facilities, like thermal chamber with humidity control. And we do have vacuum chamber for thermal vacuum test. And then we have the metal. Oh, think about that. It's not about making measurements, it's making accurate measurements. And to make accurate measurements, you have to have traceability. And all is about traceable sensors for the calibration purpose of your features. So from standard temperature and humidity sensor to accelerometers. And then we have the metrological lab. The metrological lab is the end of the chain. What's the end of the chain? Well, the end of the chain is a lab where you do have national standards, as the one in the INRIM, for example, or in our case, we do have experimental cesium-Fontaine frequency standard, as well as commercial cesium standard. But this is what we have in terms of something that we built inside. Then, of course, stabilized laser, optical test, optical tables and equipment, and other apparatus from the measurements of G. With height-sensitive tilt meters, 100 picoradians, just to give you an example of what we are talking about, and dimensional metrology equipment, as well as ultra-high vacuum equipment. So, those are the labs. Now, what we can provide? What are our expertise? Why you should call us, say, hey, Andrea, I have a problem. Well, because we do have some expertise. In what? In microwave measurements metrology, in transistor linear and nonlinear characterization, in high power microwave measurements, and in millimeter wave measurements. We do have expertise in sensor and instrumentation development, as most in the characterization of them, in development of custom microcontroller-based instrumentation. You may say, oh, I do custom microcontroller-based instrumentation. It's true. What's the difference? Is that we, as measurements people, we always think about the metrological aspect of what you design or what you are thinking of design. And this is not common at all. So signal processing for measurements application is our field. I'm always say to myself, I'm doing vector network analyzer calibration algorithm. And just to describe them, I say I do signal processing for microwave measurements, which is obviously my colleagues in telecommunications say, we do signal processing. This is obviously not the case. We all do signal processing today. It's just the matter of where you are focused on that specific topics or where we are focused, for example, of improving the accuracy. I'm almost sure that if I would have cooperated with many of you, I would probably do much better research, but this was, unfortunately, due to the structure that we are imposed over us. Metrology. Metrology, time and frequency metrology, fundamental gravitational metrology. Frequency stability of oscillator, laser stabilization, dimensional metrology. Those are typical expertise that some of us has. Looking for the tiny, tiny, tiny inaccuracy stuff and try to improve it. While all the other are, well, with the meter, they're looking for the picoradian, which is something strange, I have to say. Then some research activities. Linear measurements, two-port S parameter measurements, multi-port S parameter measurements. We are the first, many, many years ago, to study these kind of things. And recently, we are the first to have the first differential load pool test bench that was used by many companies. They came here and asked us to make the measurements. Or innovative fiber optical sensor. This is done, as I said, we are broad spectrum by definition. So this is done by in cooperation with the electromagnetic group. Glass optical fibers, plastic optical fibers, like in the way to develop in the sensor and developing the metrological capability. Or other strange sensor, for example, sensor for the from the industry, for the testing and verifying the vacuum condition, or for portable vocal signal monitoring, as well as wireless sensor network with an integration of innovative sensor. For example, structural monitoring. This is an example of the sensor placed inside the German synagogue and the Guarini chapel. Food and health application, like the cold chain monitor. This is important. Clearly, those are all applications that, in a certain sense, many of us do in other fields. As I said, the difference is that we take care, in particular, of what is the metrological aspect of the things. And then the more basic, like measurements of the black body radiation shifts in cesium standards, evaluation of the Newtonian constant G. I don't have pictures on this because honestly, very difficult experiment, and I don't really understand exactly what you have to do and how deeply you have to do. It's too far from what I am. When you were talking sub-micrometer level, I raise up my hand and say, okay. It's too far. And then, this is even more funny things, and that's Professor De Marchi, what he's doing. He's doing some frequency domain analysis of thermal phenomena with the Peltier-enabled sine wave thermal study. And he has something that I left to later to Grivet, to Professor Grivet, to talk about the half pole that Professor De Marchi is investigating. So, then there is another research activity which is done in cooperation with the INRIM, the development of atomic frequency standards, remote absolute frequency measurements, and Boltzmann constant. So at the end, many years ago, I found out these things. The most important aspect of any phenomenon from a mathematical point of view is that of a measurable quantity. I shall therefore consider electrical phenomena chiefly with a view to their measurements, describing the method of measurement, and defining the standard on which they depend. I was looking something that makes myself in this department. Now guess who said so? Thank you for the attention.